everyone, welcome back to my YouTube channel. Again, my name is Rica Mae S Casabuena from ECE21, and for today's episode, we will be having our midterm examination for Digital Electronics 2, wherein we will be creating a program for our 1, 5, and 10 peso as our digital input through our coin acceptor with LED as our output indicator. So this is a coin acceptor application using our mplab softwares, which will be our midterm exam for our Digital Electronics 2. And this is submitted by yours truly and submitted to Engineer Longares, our Digital Electronics 2 professor. So for our summative assessment 2, or our midterm exam, we are challenged to create a source code for a PIC microcontroller that will perform the conditions below. So first one, when we insert a 1 peso coin in our coin acceptor, the LED at port B0 will toggle or will turn on and off. And the second condition is that when we insert a 5 peso coin in our coin acceptor, the LED at port B1 will toggle as well, okay? And the third condition is that when a 10 peso coin is inserted in the coin acceptor, the LED at port B2 will toggle. So the challenge, the challenge here is that aside from the programming, we should configure or reprogram our coin acceptor wherein it will accept both old and new coins, okay? So we should submit our video documentation and vlog as the proof of our answer. So I hope you'll have fun with the midterm exam and enjoy watching my video. We will be having these objectives, which is to create a flowchart that depicts the logic of the program code on the mplab software. Second is, of course, to create the mplab source code that will be correct for the application of the coin acceptor. And the third one is to use the PIC history correctly with our mplab to program our IC, okay, so we can use it in our actual circuit board, which will be depicting or showing the logic behind the coffee and tea vending machine that we are using to supply our beverages needs. So for our equipments and components, we will be using this IC, the PIC16F18875, 360 ohm resistor, LEDs of different colors, so we can acknowledge, okay, we can distinguish the 1, the 5, and the 10 peso coin output, breadboard, connecting wires, picket-3, power supply, 10 kilo ohm potentiometer, okay, for our pull-up resistor, 12 volts for our coin acceptor, and 5 volts for our circuit, and then the coin acceptor itself, and our alligator clips to connect our voltage supplies. So we already explained this one. Let's go to our flowchart. So first, explaining our flowchart, we will be considering start. Then we should initialize 1 pin of our port as our digital input and our 3 LED as our digital outputs. So we will treat L1, okay, the source code L1, L5, L10 as our outputs, okay? And for our decision for the program, we will be asking, is 1 peso coin inserted? If it is false, then it will go back to this loop. But if it is true, then our L1 or our LED for 1 peso is set high, and the rest of the LEDs 5 and 10 will be set low. For our second decision, we will be asking if 5 peso coin is inserted. So if it is false, let's go back to the loop of asking or making decision. And if it is true, the L5 or the LED for 5 peso will be set high, and the rest of the LEDs will be set low. Okay, and then for our third decision, is 10 peso coin inserted? If it is false, then we will go back to the loop to ask again for the decision. And if it is true, our LED 1 and our LED 5 will be set low, and our LED 10 will be set high or will be lit up, will be lighting up. So we will return to create a loop with our code. So every time we insert a coin, the timer 0 will be 0, and our count will be going back to 0, or it will automatically reset. And after that, if there is no coin inserted, that will be the end of our program. So that's the flowchart and the logic behind our source code. So now we will be going to our mplab. Now, to start with our program, we should open our mplab IDE, and then we should create a new project, and then microchip embedded, and then a standalone project. So let's use our PIC, okay, let's use our PIC16F18875 IC, which is the IC that we are using. And we should click next. We should select our compiler here, and this should be named midterm, okay, midterm exam Casabuena, nice name, and we should save it to the right folder, and then let's click finish. Let's wait for it to load up so that we can create our source code already. So now let's click our MCC here, and let's wait for a pop-up that will allow us to save our MCC project. Okay, so let's just save this one, and let's wait for our print monitor to load up correctly. Okay, so here on the side, we should select the right package for our IC, which is this long one here, okay, which is for our PIC 16F18875. So in this midterm examination, we will be using the timer 0 because this is a simpler approach in making our source code, and it will provide a counter in our program. So to use the timer 0 under the device resources, we should add our timer 0 option here, okay? So we should add this one, timer 0. We should select this add button here, and as you can see, in our peripherals, timer 0 is already added. So in our timer 0 setup, we should keep this parameters as is, okay? Our clock prescaler is 1:1, post scaler is 1:1. We will be using an 8-bit timer mode, and our clock source should be a timer 0 clock pin, as you can see here. External frequency is SSS, so 100 kHz, and our requested period SSS as well, which is 2.56 milliseconds. So enable synchronization should be ticked or should be clicked, and enable timer interrupt should be clicked as well. So after this one, we should go to our pin manager here, and going back to our word file here. So when a 1 peso coin is inserted, the LED at port 0 will toggle. When 5 is inserted, port 1, LED at port 1, port B1 will toggle. And when a 10 peso coin is inserted, the LED at port B2 will toggle. So we should remember these ports because this will serve as our output ports where the LED will be connected. So as you can see here, our timer 0 here has already been selected as our input, okay? So if you can still remember, we should treat port B0 as our output. So let's click this one. This will be our output. And port B1 should be an output as well for the 5 peso coin. And port B2 should be an output for the 10 peso coin. And after selecting our output pins, we should go to our pin module, okay, pin module here, and we should rename this RB0, RB1, and RB2 as our output. So as for me, I want to rename this one L, okay, RB0, since it will be connected to our LED, which will toggle when we insert a 1 peso coin, so I should rename this L1, okay, then RB1 should be renamed L5, because it will toggle when 5 peso coin is inserted, and our RB2 should be renamed L10. So this analog should be on click, but output should be click because it will be our output pins. And notably, for our RE4 here, which is our timer 0, which gives us a timer 0 clock, we will be clicking WPU. So again, reiterating, our L_1 here is our indicator for the 1 peso coin, okay? L_5 is for the 5 peso coin, and L_10 is for the 10 peso coin. And these indicators will let our LED toggle connected to this specific IC port. So let's go to our system module and make sure that oscillator select is HFI and TOSC. HF internal clock is 4 MHz and clock divider is 4, and our low voltage programming should be enabled. So after rechecking all of that, so let's generate our code or our settings. So let's wait for the generation complete to pop up. Okay, generation completed is already displayed on our monitor, so we will be creating our source code. So now creating our source code, let's go to our midterm exam file here. Okay, so let's go to our. So from here, let's open our source file, and we will be opening our main.c file here, which we will be encoding our source code, and we should open timer0.c file as well. So we will also be loading our header files here, and we shall find the pin_manager.h. So timer0.c should be opened, main.c file should be open as well, and this one, pin_manager.h file. So notably, before we create our source code and our main.c file here, okay, under this while loop, we should find this read timer option here, which is our UINTA_T timer0_read timer void. Okay, so this is really important for our source code under the main C file to be able to read the function of the timer 0 that we added a while ago on our settings. So after copying the important code from our timer0.c file here, we should paste it here under our while loop, and then this one, okay, this one should be copied and should be recognized before our while loop. So we should put it here above, and we should add, okay, this is important, we should add a count, we should add another source code here, which is count, which will let us perform another function in mplab. So do not forget our semicolon, and then while one, and then our copied timer0_read timer. So now we shall create our source code. So since we already encoded this count program here, we should replace this one with our count, okay, with our count code. That will let our timer 0 perform its function. So now let's start creating our program. explaining our code, using our timer 0 underscore read timer here, which we copied from timer0.c file, we are able to establish a source code using this uint8 underscore t, which allows the mplab program to consider a count. Okay, so this count will be 1, 5, and 10. So if we insert a 1 peso coin, if it will indicate a 1 pulse signal that will let our L underscore 1 LED to be set high and to toggle or to turn on when a 1 peso coin is inserted. Meanwhile, when our count is 5 or we inserted a 5 peso coin, our L underscore 5 here will toggle or turn on for a duration of 1 second or 1 millisecond. Same with our 1 peso coin. But if our count is 10, then it will create a 10 pulse signal that will let our L10 here to be set high or to turn on and to toggle for 1 second. So this timer 0 command here allows us to reset the count, okay? To reset the count to 0 every time there is a coin inserted. So for example, when we insert a 1 peso coin here that gives us a 1 count or a 1 pulse, after performing the function, okay, or the function of the source code here, then it will reset our timer 0 and our count to 0. So this resetting of our count enables us to not confuse our source code or our microcontroller, which will enable the programmer or the microcontroller to execute the action clearly, not being confused by the coins being inserted to the coin acceptor. Okay, so as you can see, there is a delay of 500 milliseconds before the microcontroller process or perform the action, because when we do not insert the delay, it may be confused that every time we insert a 1 peso coin or a 5 peso coin, it will be confused, and whereas the LED for the 5 peso coin will turn on even though we inserted a 1 peso coin. So that's the role of our 500 milliseconds delay here. So we also inserted a return command here, okay, that will allow the microcontroller to just repeat the process, okay, or this source code here that will allow the microcontroller or the IC to continuously repeat the execution of our source code as the user continuously insert a 1 peso, a 5 peso, and a 10 peso coin on our coin acceptor. So in the end, okay, we selected or we encoded an else-if statement wherein, okay, if all of these conditions are not satisfied, a 1 peso, a 5 peso, and a 10 peso coin is not inserted on the coin acceptor, meaning our count will be 0, okay, and there is no coin inserted on the coin acceptor, then commonly, the LED on port B0, port B1, and port B2 will not toggle or will not turn on. It will just be turned off, okay? So let me add a statement in here. So we should add a comment here in if count is 0 or there's no coin inserted on the coin acceptor, the LED will be turned off. So this is our source code for our midterm exam. So now we will be building our code. So let's just wait for it to load up. And displaying on our screen, build complete, okay? Build successful. So now let's proceed to our mplab IPE. So now, guys, we will be connecting our PK3 to our mplab IPE to program our IC or our microcontroller. So now let's connect our PK3 here, and let's wait for it to load this quotient notif here, and then let's click OK, and then we will be setting up. Now we will be setting up again. Okay, so it should be 3.125, and then power target circuit should be clicked, and then operate, and then let's browse our hex file here. So call this Rica files, ECU here, then digital lab, and then midterm exam, and then this, the full production, and then this one. Let's load our hex file, and let's click program. So programming complete will pop up. Okay, programming complete, and now let's construct our circuit. So hi guys, we already connected our PK3, okay, our PK3 to our breadboard and to our computer. So now we should disconnect our PK3 here, okay, turn off our USB cable and disconnect our PK3 here. So let's set it aside, and then we will be constructing our circuit. So we will be needing, okay, 3 LEDs. So for easier reference, we will select this green LED here as our LED connected to our RB0, which is our 1 peso indicator. Then we will select this red LED for our 5 peso, which is connected to our port B1. And then this blue LED here will be our 10 peso indicator connected to our port B2. Then we will be using 3 resistor, okay, probably 300 to 1000 resistor. And then we will be using a pull-up resistor, which is 10 kilo ohm, which is the typical value of pull-up resistor, to make sure that our 12 volts coin acceptor will not be damaging our IC. But since I don't have 10 kilo ohm resistor here, I will just be using a potentiometer, okay, which has a 10 kilo ohm, okay, let me focus, which has a 10 kilo ohm rating value. So this will serve as our 10 kilo ohm pull-up resistor. So now, starting to construct our circuit, we already set up our 3 LEDs here. Namely, the green LED will be for our 1 peso indicator, red will be for 5 peso, and then blue for our 10 peso. So our green LED, okay, our L1 is connected to our RB0, which is on the 33rd pin of our IC. So RB0 is up above VDD, so this red wire here. So since it is green, then we will be connecting a green wire here. Okay, green wire. Then let's connect it to the positive terminal, okay, of our green LED. And then the L5 or our 5 peso LED indicator is connected to our B1 or the 34th pin. So red LED, so we will be using a red wire, so connected to the positive terminal of our red LED here. And then the blue wire, okay, the blue wire will be connected to our blue LED, which is on the 35th pin of our IC, so up above the red wire. Okay, so red wire, and then this blue wire then to the positive terminal of our blue LED. So as you can see, this will be the connection. Okay, this one. Then our VSS is connected to the ground. Okay, this yellow wire should be connected to the ground, and then our VDD should be connected to the positive terminal of our voltage supply, and this one on this wire, the VDD and the VSS should be connected as well. So the red wire, okay, let's just transfer this one. The red wire should be connected to our positive terminal, and then the gray wire should be connected to our ground. Okay, as you can see here. So since the coin acceptor requires a 12 volts voltage to turn it on, and then we will be connecting it to our breadboard, it needs a common ground with our 5 volts. So we will be selecting or setting up a common ground for 12 volts and a 5 volts voltage supply. Okay, so this black wire here will represent our common ground for our 12 volts, okay, which will be connected to this black wire here, which is connected to our coin acceptor. Okay, and then this another black wire here. Let's select another black wire, or black wire. Let's select this second black wire as our ground, which is connected to our 5 volts DC voltage supply. So this 5 volts here will be connected to this alligator clip, which is connected to the ground of our 5 volts, okay? And this black wire here will be connected to this black wire, which is the ground of our coin acceptor. So we will be connecting both of them using our alligator clip, okay? This will share the common ground. And then let's connect the 5 volts of our, the positive terminal of our 5 volts. And then we will be connecting the counter or the white wire from our coin acceptor. This will serve as our digital input, okay, that will be performing the function of the timer 0, which is connected to the RA4. So since we will not be directly connecting the white wire of the coin acceptor to the IC, because it may result to a malfunction of our IC, we will be using a potentiometer as our pull-up resistor. This is 10 kilo ohm, okay? So from 0, I'll just adjust it to its maximum rating, so it will give me a 10 kilo ohm resistance. So let's connect this one. Okay, let's connect this one to our circuit. So let's connect it properly. So as you can see, our potentiometer is already connected. So with this one, okay, let's just transfer this one. Let's connect the first terminal of our potentiometer. So now let's connect the first pin of our potentiometer. So here, let's connect this to our 5 volts, okay? So this 5 volts here of our 5 volts voltage supply, and then the second pin, okay, let's use a yellow wire. The second pin should be connected, okay, where's the second pin? The second pin should be connected to the coin acceptor output, which is the white wire here, which is the coin wire from our coin acceptor. So let's connect this one, and then with that, we will be connecting as well this second pin of the potentiometer, which is connected to our coin input to our RA4, or to our pin number 6 of our IC, which is the timer 0 clock, which will perform its function. So let's just count from our IC. So this is 1, 2, 3, 4, 5, 6. So this pin number 6 here, and our third pin, okay, this will be the connection. As you can see, it's a bit complicated. So the last pin of the last terminal of our potentiometer should be connected to the ground, okay, should be connected to the ground of our 5 volts here on the other side, or in this area here. So this will be our connection, okay. So lastly, let's connect our voltage supply. So let's connect our 5 volts here, okay, positive polarity of our 5 volts to the positive polarity of, our voltage supply, and then the negative polarity should be connected. So this green wire here should be connected to the negative polarity, and then our coin acceptor should be connected to our wire here, okay, the common ground. They will be sharing a common ground. And then lastly, we should connect our red wire here, okay, our red wire of the coin acceptor to the positive terminal of our 12 volts DC supply. So now we will be testing our circuit. So now before testing, this will be our circuit construction overall with our midterm exam. Hi guys, for our results, now we will be inserting an old 1 peso coin to our coin acceptor. Okay, as you can see, so this is our old 1 peso coin. We will be inserting it in our coin acceptor. So this green LED here should light up when we insert an old 1 peso coin. So let's try. Okay, as you can see, the green LED light up. So another one. Okay. Another one. Okay, as you can see, as we enter an old 1 peso coin, our green LED is lighting up, which proves that our program is correct. Okay, so now we will be testing our new 1 peso coin. So as you can see here, okay, so this is our new 1 peso coin, and we will be proving that our coin acceptor has been pre-configured or reprogrammed correctly, and it was able to recognize a new 1 peso coin. So let's insert the new one. Okay, as you can see, it also light up the green LED. So let's try another one. Okay, it light up again, and then the next new 1 peso coin, and then the last new 1 peso coin. Okay, so as you can see, our 1 peso coin, which is the new one and the old one, is being recognized by our coin acceptor and light up our green LED. Now, for the next proof that our coin acceptor is working and our program as well, we will be inserting an old, an old 5 peso coin to our coin acceptor, as you can see here. So now let's start. Once we enter our 5 peso coin, which is the old one, the red LED here should light up. So let's start. Okay, as you can see, our red LED light up when we enter the old 5 peso coin. Okay, and let's enter another one. Oh, another one. Okay, and the last one. Okay, so that's our old 5 peso coin. Okay, so as you can see, every time we insert a 5 peso old coin in our coin acceptor, it turns on. Now we will be testing if the coin acceptor accepts a new 5 peso coin, just like this one here. So now we will be entering it to our coin acceptor, and our red LED should light up. So as you can see, our red LED light up here. Okay, another one. Another one. Another one. Yeah, so that proves that our source code and our coin acceptor is reconfigured correctly. Now, for our last test, we will be checking if our old 10 peso coin is being recognized by our coin acceptor, and once we enter the 10 peso coin, which is the old one, the blue LED here will light up. So now, let's test our circuit. Okay, that's one. So as you can see, when we entered the 10 peso coin, our blue LED light up here. So let's try another one. Okay, it light up again. So let's try another one. Okay, so that's another one. And then for our last one. Okay, so as you can see, as we drop or enter our 10 peso coin, which is the old one, the blue LED light up here. Okay, so that's the checking on our circuit. Now, for our last test, we will be testing if this new 10 peso coin is being recognized by our coin acceptor. And once we enter the new 10 peso coin here, this blue LED will light up. So now, we will be testing the circuit. So, focus on the blue LED. Okay, as you can see, the blue LED light up when we enter the 10 peso coin. So, the next one. Okay, so that's another one. The next one. Okay, so that's another one. Okay, so let's try more. So again, this will be the coin, the new 10 peso coin. Okay, as you can see, the blue LED is lighting up. Okay, and for the last one. Okay, so that proves that our source code and our circuit connection is correct, which let us realize that through the right connection and through the right source code using our mplab, we will be able to control our LEDs using the input or the digital input through our coin acceptor. So that's our midterm exam. Thank you. And again, my name is Rica Mae S. Casabuena. Keep safe and God bless. Bye for now.